Great. Thank you. Thank you, everyone. Good morning, good afternoon, good evening, everyone. So it's good to be here at this Games conference. My name is Nalin Arachchilage, and I'm a lecturer in cybersecurity and privacy at the University of Auckland. Today, I'm going to be talking about software developers need education. Of course, they need education. They need a bit of matters, particularly when they're asked to develop privacy-preserving software systems. So why privacy? Why is it important for us to understand privacy? Privacy is so important as well as security. Security is where we need to keep our systems secure and safe. At the same time, we need to preserve end users' privacy when they're asked to engage with the systems and have that particularly essential services through the systems that they're using. I'll give an example. Here is the ME Safe Driver app. So that poses a lot of threats through this. But ME app is being designed to give off-road or roadside assistance to the users, to the drivers, particularly the new drivers, welcome. So, however, their GPS logs not only reveal where you travel, how fast you drive, which route you take, as well as which ATM you stop by. Where were you at the last Friday night? So all of these information, they are going to collect the rider's information. So it is a privacy threat. What happened if they disclose this information to the police? If you were behind the wheel after a couple of beers. So this is the threat that they could pose against those individuals. And they have not been notified how they collect this information, how they store their information, how they share these information with a third party. So when software developers are asked to develop systems, it is very important we have to understand they know how to incorporate privacy into the application. Otherwise, we design and develop systems without having privacy incorporated. So we can't expect end user to use the system, consume the service through the systems that we design and preserve their privacy. So this is another example. When we develop the system, as well as when we have the policies presented along with the system, this is how Twitter going to provide their privacy policy. They're going to communicate their privacy policy to the end user. So they have got 19 pages. So they're particularly talking about the legalese words, and it is very difficult for an average person to understand. If you really put them into hours, and it literally takes average internet users around 244 hours to read every privacy policy for every website that they have visited. And this is huge, and this is very difficult. For example, when you work for an organization, so basically you're expected to read all of these privacy policies if you know what I mean. And literally takes a study conducted by Professor Crown from Carnegie Mellon University that talk about, at least it takes 76 days to read those privacy policy, which is around more than nearly 3 months per year, which is a lot actually. And also the other problem is these privacy policies are being designed having lawyers protecting themselves in their mind rather than end users in mind. So this is the challenging bit. And when it comes to communicate those policy updates, and how do they communicate? So will people understand? That's another question. This is a good example of Viber. Viber wants people to accept and continue the privacy policy even before they pivot. So they actually, it turns out to be that they don't really want their end users to read their privacy policy, because if they read their privacy policy, so they perceive sort of a threat and maybe quite reluctant to not use the system. So that turns out to be they might have a lesser number of people using that system. So that's why they don't want to do it, because, and also this is against their business model as well. So think of another situation, Zoom bombing. We're all quite familiar with after the pandemic, and we have experienced those. A lot of people used to, bring work, unfinished work, home, as well as, started continuing to do the work from home. As a result of that, and the Zoom, people use the Zoom platform a lot because it provides a high level of communication, having conferences like the current conference that I'm speaking to. So they are, it is a good platform. So, however, it's also, we have experienced the Zoom bombing thing early last year, and many have reported being attacked by uninvited guests. So this is a good example. This is the moment the UK Prime Minister, Boris Johnson, has been experiencing Zoom bombing thing, and one of the intruders, the uninvited guest, sneaked into his the communication and intersect, and also eavesdropping. And so this could even escalate to a threat of democracy and national threat as well, because this is a very important, if they're talking about military issues with a particular country, and this sensitive issues of a particular country, and this is going to escalate to that level as well. So therefore, even heads of states need some help with the technology, particularly communication technology we are using. So the question, and also we have experienced those Zoom bombing thing, the hackers, the attackers, when those stolen accounts have been shared on the dark web, which is not so good. And this is all talk about how badly, how poorly we design systems, lack of previous integration. So at the end of the day, we can't expect end user to use those systems and preserve their privacy. So we need to educate programmers, software developers, architects. So all of these, the people who create software to write a better secure code, better software that preserves end user privacy. Here is another example. Uber data breach. The Uber concealed actually a hack affected by 57 million customers, drivers and riders' information, including their names, email addresses, mobile phone numbers. Actually, this is not really recommended thing. As a cybersecurity professional or practitioner, we can't recommend people to pay and get their data back. So, however, Uber, they pay the hackers around $100,000 dollars to delete their data, which is atrocious. That they shouldn't do it. In New Zealand government, we know that we are abide by the law that we have to disclose every organization, any institutions, organization, they have to disclose if the particular incident happened within 72 hours, they have to disclose to their privacy commissioner. So according to the Privacy Act that they have introduced 2020, so they're abide by the law that they have to notify to the Privacy Commissioner about such incidents related to cybercrime and other cybersecurity issues. So Uber failed to do that, or they chose not to, because they know what would be the detrimental effect that they would face in the future in terms of running their business and profit, and it is going to a threat to their business, and that turns out to be, so many organizations are going to face the similar incident, and also they're trying to conceal a hack after that incident happened. So which is not so good. And if you dig deeper and try to realize where the problem is, the problem's with the engineers. And also, I believe the software developers, engineers, security professionals who create and design those systems are equally responsible in this case. So therefore, we wanted to dig deeper to realize why software developers cannot embed privacy into the software systems. And we wrote the first paper in this particular area in the privacy context, and received the Best Paper Award. We have received the award from Christchurch, the conference, one of the top software engineering conferences that was held in Christchurch, New Zealand as well, back in 2016. So we have identified why software developers cannot embed privacy into the application. And we found that they haven't got sufficient knowledge. We have GDPR. GDPR came into force after the Cambridge Analytica Institute, where we have a privacy impact assessment. We do have privacy by design. We have a number of techniques, tools, methodologies, but software developers fail to transform them into reality when they're asked to develop privacy-preserving software systems because there is a lack of methodological support. So in this talk, I'm going to solely talk about the methodology we develop, helping software developers to transform privacy into reality in the wild while they're asked to develop a privacy-preserving software systems through a gamification platform. Let me talk about, first, let me talk about the methodology that we develop. And then we will talk about the gamification approach we develop to facilitating them to transform get this idea across the software development community. So we use one of the principles called data minimization. So when we collect data, so the issue with privacy is how you collect data, how you store their information, how they share, you're going to share the individuals, people's information through the systems. So they need to be well aligned with GDPR or any principles that we are adhering within the particular country. Sometimes we have a universal thing called GDPR, came into force 2015, but every organization, say sometimes different countries, they may have the adapted version. So the GDPR, all of these privacy acts, they're solely focusing on how the system is going to collect the data, store the data, as well as share the data with third party, for example, advertisement purposes. So we wanted to be able to identify when we design the systems, how the systems are going to collect data, understanding data. Software developers need to be able to understand data and calculate the perceived privacy risks. We develop a mathematical model multiplying sensitivity, how sensitive the data, the visibility of the data, how visible that data is in the general public. For example, sharing your information through Facebook, visibility of the data, how visible, relatedness of the data, how that data would be related. For example, you might be sharing your Gmail account or Gmail address with your friends where they can contact you. But that's a username you're using for logging into the Gmail account. But however, would you do the same sharing with your banking username? Or would the bank use your Gmail account as the login when you ask to log into your banking account, online banking account? You wouldn't. So the relatedness would be really important. We develop a mathematical formula model to calculate the individual's perceived privacy risks. So once they understand the perceived privacy risks of associated with every data point when they collect during the requirement gathering, and then they can also think of carefully when they come to design and development of the systems, design the front end of the systems, design the back end of the systems. And then once they have a better idea about it, they should also be able to come up with the system design decisions, as I mentioned that earlier. How do we collect those information? How do we collect individuals' information? And how do we share them and store their information? And also how do we share their information, for example, advertisement purposes or sharing with their parential company sometimes. So once we've developed this methodology, we wanted to test through the users, particularly software developers, because they are the ones that are using this methodology, the model, to implement privacy into the application that they are asked to develop. So we wanted to see their adoption, and they found this model is usable and very adaptive in the wild. While they are asked to develop software systems, this model gives them a precise information and practical usage, and they found it very useful, and they found it easy to adapt. Adaptability was quite high. And also they say they are quite highly likely to use such a model. However, we wanted to then get this model across the community. Here we are going to talk about how we develop a game as an educational intervention where software developers can use this game to educate themselves. So the game solely focused on enhancing developers' secure coding behavior through their motivation. So here is the initial framework we have developed for software developers to enhance secure coding behavior through their motivation. Which I mean here, secure coding behavior, that is actually how they can write a secure code to enhance the individual's privacy, preserve individuals' privacy through their motivation. So initially they should feel such a threat, because when the software engineers, they wouldn't actually go and develop a system unless they feel threat perception. So we wanted to design a game, getting them immersed into a real world scenario like Zoom bombing, taking them through the Zoom bombing incident scenario and getting them to exposed into that scenario where they feel, wow, this is really, really important. We have to really think about end users' data privacy or privacy in general. So that is influenced by perceived threat. Perceived privacy threat is influenced by perceived severity and susceptibility. How often this Zoom bombing thing could happen? If the particular Zoom bombing thing happened, what would be the financial loss? What would be the reputation damage to the organization that they're using our system? And in return, how that will impact on our organization that I'm working for. That means software developers company that he is serving, that he is working for. So now you feel, wow, this is really important, but I don't know what to do with that. So I don't have a self-confidence to enhance my behavior in writing a secure code in terms of developing a privacy-preserving software system. So this is where we used our data minimization model, letting them to understand and calculate the perceived privacy risks with each and every data points that they're collecting during the requirement gathering and analyzing stage. And then they can come up with the design decisions case, system design decisions level, so back-end design as well as front-end designs, where they can have, because we calculate the perceived privacy risk, we can identify the top risk and the medium ones as well as the low risks. It goes as case by case. So then they can come up with the system design decisions where how they collect this information through the systems, how we collect individuals' data points through the systems, how do we store their information, how do we design it, how do we share this information with third-party companies as well as our parential company. So they would be able to come with that. So we wanted to get this model incorporated to the game design platform through the Bloom's taxonomy, which provides the practical approach, step-by-step approach, where they can get this theoretical learning model to a pragmatic situation through a step-by-step approach developed by, according to Bloom's taxonomy. In turn, they would be able to enhance their self-efficacy, how confident they are to write a secure code in terms of developing a privacy preserving software systems, in this case, through a gamification platform. This is the overarching objective of gamification platform framework we developed to enhance individuals' privacy preserving software development behavior. So once we've developed, we wanted to test the game through the individuals. We developed through the literature and real world situation understanding through a qualitative study, what we call grounded theory approach. But we wanted to dig deep and realize how actually their mental model works in terms of enhancing their secure coding behavior through motivations, how those psychological element works in reality, in the wild. So we wanted, the next challenge is we wanted to get the psychological element incorporated into the game design platform with a story that simplifies and perhaps exaggerate real life, and where they can get themselves immersed into a situation where they can have a better experience. So we wanted to take them through real world situations with better interactions where they're immersed into the gamification environment through various persuasive design principles in HCI. So then we can get individual software developers, game players interacted to the platform. And then we can understand how they enhance their avoidance behavior. We can have a pre-test and the post-test and try to understand how the awareness has been increased, as well as their psychological elements. So when we are planning to use the Think Aloud study environment to capture how the individual's psychological element, how they perceive threat, how those severity, perceived privacy, severity, as well as susceptibility will influence on their threat perception. And also we try to understand how can we enhance their individual's self-efficacy, how confident they are through a gamification platform. So we also wanted to think about the knowledge representations, how we can use the gamification tools to get this message across the community. Not only gamification, not only privacy is important to implement into the systems, but also it helps to enhance their developers' self-confidence, how confident they are learning and applying those concepts and content that they have learned through the data minimization model, which we have developed, enabling them to write a secure code in terms of developing perceived privacy risks. So that is the end of the presentation, and I would take any questions at this point. And thank you very much for listening, and enjoy the rest of the day.